Hey, Bsauce.
Brian here. But where is here? And where am I? The universe. But what is a universe? And what is it doing? For quite a while, we've known that the universe is expanding by observing the Doppler effect, which also affects the emitted light from stars. Stars moving toward the Earth have an apparent decrease in wavelength, called blue shift, while stars moving away have an apparent increase, called redshift. The greater the speed of the object, the greater its shift. Mr. Edwin Hubble noticed that an object's redshift was proportional to its distance from the Earth, allowing him to determine the Hubble constant that showed a constant expansion rate of the universe. So there you go, the universe is expanding at a constant rate.
Or is it?
In the late 90s, astronomers Brian Schmidt and Saul Perlmutter both were engaged in the research of the distant supernovae of white dwarf stars. These smart fellows use these supernovae because they are very well understood and their actual wavelengths can be predicted quite accurately, thus allowing for easy comparisons between actual wavelength and observed wavelength that is distorted by the Doppler effect. And by observing their spectra, they both realized that the redshift was much less than what the Hubble constant predicted, meaning they were not traveling as fast as the constant rate of expansion Hubble hypothesized. Now, because these supernovas were billions of light years away, the emitted light they were observing was also from billions of years in the past, given the time it took for the light to reach Earth. And since they discovered that the universe was not expanding as fast in the past, they concluded that the universe must be accelerating, earning them the Nobel Prize in Physics. But you may be asking, why is the universe's expansion accelerating? Our traditional model of the universe had galactic matter moving at a constant velocity, given by the Hubble constant, and that the only thing that could possibly stop or reverse this expansion would be the effect of gravity. So why then would the universe be accelerating? Astronomers realized that in order for the universe to accelerate, there must be an outside force, and as a means to explain this force, they theorized an unobservable energy creating it, which they named dark energy. It's called dark energy because we have no way of studying it directly. Rather, we can only observe its effects on its surroundings. And as a result, dark energy continues to be not very well understood by physicists. Some hypothesize it is an intrinsic property of space, and so as the universe expands into more space, it comes into contact with more dark matter, contributing to further acceleration. Others hypothesize that dark energy acts as a fluid-like substance, occupying the space within the universe, only that it has a negative pressure field that contributes to the universe's acceleration. And lastly, some think that dark energy demonstrates that we don't fully understand the nature of gravity, and our entire understanding of it could be false. But anyway, the point is the universe is expanding, and it's also accelerating in its expansion. And if you ask me, that's pretty cool, aha! And remember,
you don't have to wear a cape to be a hero, but if you want to, that's okay. And as always, thanks for watching!